All right, a very good morning to everyone who are with us. I am Adro, and I will be hosting today's Steam Trivia for the Steam Trivia Season 2, Week 5, regarding the Pythagorean Theorem. So, for all those who are with us this early morning, you may start by again preparing two screens, one to view the questions and slides from your laptop, and another device like your phone to answer the questions. So from your phone, you can go to Kahoot.it and type in the game pin at the lower right of this screen. Okay, that is 3007101, and you will join our Kahoot game for questions and answers later. Also, for today's stream, please prepare a calculator as there will be some calculations involved since we will be learning. Since today's theme is about mathematics as part of the last letter of the STEAM. Also, I would also like to make it known that for this week's quiz, there will be 3 winners instead of just one. So all you who are joining us, do feel encouraged to participate more and have a higher chance of winning a prize. Yeah, so not only will there be one winner, but we have increased the number of winners to 3. So all of you will get a PISF t-shirt. All right, and with that, let us begin today's STEAM trivia, shall we? All right, so what is the Pythagorean Theorem? All right, as you can see, this smart boy looking at it, all right, it is roughly this picture itself. You have the triangle, you have the numbers, but again, like, what is it? Is it art? This picture shows you the Pythagorean spiral. So is it that? Or is it just maths, like when you calculate the angles, the lengths, the distance, and whatnot? Or is it like a bit of both, where yes, it's maths, but you can also use it for arts, and it is the art of calculating numbers. How do you play around with numbers? All right. So let's just get straight into the meat of it. All right. What is Pythagoras theorem? Pythagoras theorem itself, it's a mathematical law that states that the square of the hypotenuse is equal to the sum of the squares of the other sides of a right angle triangle. So yes, it's a very big mouthful, but basically it means the formula itself. A square plus B square equals to C square. C square is the hypotenuse, the side of the triangle opposite of the right angle. The right angle being where it is 90 degrees. And also, A and B are the two other sides. So what it states that when you take A and B, you square them, meaning you times itself, A times A, and also B times B. Add them together, it will become the same amount of C times C, which is C squared. So that is basically the formula for the Pythagoras theorem. Also, feel free to comment in the live stream. I'll be keeping watch on any comments or any questions that you have, and I'll try to answer them as promptly as possible. All right, on to the next one then. All right, so a quick quiz. The Pythagorean theorem can only be used when the triangle is you have 4 answers here, or 4 options here. You have an acute angle, an obtuse triangle, a right triangle, and a isosceles triangle. All right, most of you click correct. Yes, you can usually use the Pythagorean theorem when you have a right triangle, because again, one of the conditions for it is that you must have the 90-degree angle. So we have Perry Dragon in the lead, followed by Smiling Ibex and the Amazon hare. Oh, hare from Amazon. All right. So just to explain a bit on the question, yes, you will need a right angle triangle, but here's the beauty about triangles, which I just wanted to point out, which is very interesting and very fun. Almost all triangles, there is a right triangle within it. Like for example, here you have a acute triangle. Assuming that it must be acute, it might be right. But whenever you halve a triangle, forming a line in between here, you will automatically get a right angle here when you draw a line perpendicular to the bottom side. So by just doing that, you actually form one right angle on the left, which is from the tip down to the middle to the other end, and another right triangle on the left-hand side. So just by doing that, you can actually use the Pythagorean theorem from almost any triangle. Just that you need to find a proper side where you cut it through and form a right angle in the triangle, forming a smaller triangle within the larger non-right triangle. All right. So again, just to remind you, what is the Pythagorean theorem? Pythagorean theorem is stating that you can take the two sides, square them, and add them together to find the square length of the hypotenuse. Any questions so far? Nope. All right. And so here, earlier I was talking about the Pythagorean spiral. So what is the Pythagorean spiral? Is basically you taking the Pythagorean theorem and creating more right angle triangles where you can know the lengths of each hypotenuse. So starting from the first one, let's look at the very middle one where you have 1 third, and 2 third. All right. Again, 1 square is 1 square. Third one is third. So, sorry, third one square is 1. So 1 square, again with 1, you add together becomes 2. And again, hypotenuse is it has to be squared first, then you get the sum. So going down from a square, you have to third it. So therefore the hypotenuse here is a third 2. But this is just if you're interested in the hypotenuse. The beauty about the Pythagorean spiral is that you can just keep on using the right angle side to create more, to extend the spiral, and then it will never, quote unquote, get in each other's way. Is because as you increase in length, because the hypotenuse is always longer, your sides will gradually grow longer, and therefore your spiral will slowly extend outwards, and therefore you won't become a circle but a outward extending spiral. So how is this used in arts? Here are some art ideas. You can actually use it to draw a chameleon's tail on the above left of the collage, or you can draw a shellfish in the top middle, an eye if you're feeling a bit artsy, on the top right, and also Nike's helmet can also look like a Pythagorean spiral, as you can see from the bottom left, or a nautilus, another type of sea creature that actually looks like this, and also a football helmet, again mirroring the theme of helmets where you use to cover your head. So yeah, if you feel up to it, where you have a lot of free time and want to express yourself through maths, this is one of the ways you can do it. But there's another thing about Pythagoras theorem that you can use related to drawing or related to outdoors in this sense. It's also an outdoor tool where you can use it in real life, not just on paper or drawings, but in actual three-dimensional spaces, I would say. So since maths are all around us, because there are patterns in the world, we can also use the Pythagorean theorem in certain outdoor activities. Can any of you guess what are those activities? You can put it in the comment. Let's say, for example, look at the picture. Do you all see any thing related to the Pythagorean theorem. Like for example, we know the Pythagorean theorem, we need to know the length. We need to know whether is there a right angle, and you just need to square the sides to find the hypotenuse. So one very simple feature in real life which resembles a triangle would be mountains, as you can see from this picture, or even trees itself, a very long form of triangle. So you can actually use the Pythagorean theorem to calculate how steep are the gradients of those hills, those trees, or anything triangular shape. All right. So, for example, can you all try to guess where is this? All right. You have the Diwali pinnacles. You have the Alexandria Peak. You have the Oyayubi Iwu Peak, the Victoria Peak, Lowe's Peak, St. John's Peak, South Peak, Ugly Sisters Peak, Donkey Ears Peak, Tunku Abdul Rahman Peak, and also Kemuncak Ramitan. All right, this is a location in Malaysia, and if any one of you are familiar with it, can you try to guess, or more accurately, after knowing where this is or which mountain this is, can you actually try to realize the shape of it? Because again, this is something special I want to introduce to you regarding a concept that uses the Pythagorean theorem. No? Okay. So this is actually Mount Kinabalu. All right. Earlier you saw if you could have seen the contour lines, all right, they are actually telling you the shape of the mountain. So again, earlier where the marker is set, that was Lowe's Peak, the highest point in Mount Kinabalu. All right. Okay. Right. So what is this field of study in which you study the actual terrain or the features of land? So it's called topography. All right. Topography is used to describe the detailed study of Earth's surface. This includes the changes in the surface, such as mountains and valleys, as well as features such as rivers and roads. So if you remember earlier, that you could have seen a road going from the bottom of the map going up towards the peak, Lowe's Peak. As well as you can see this dark area, there's a valley here because again the sun is casting from the mountain over to the lower regions, which is a valley. Therefore, the shadow forms in the valley. Over here, if you can see. Okay. And also for peaks, you can see a peak here, peak being the highest point of a mountain. So how do you see peaks from a map? It's very easy. You just find if you can see any shadows, roughly the middle part of it, those are peaks. Okay, sorry, resume. Okay, so again, these lines, we call them contour lines, okay, or isolines, okay. These lines are supposed to represent the elevation. So if you remember from the Pythagorean theorem, you have the two lengths of a triangle, but these two lengths, you do not see them as if flat on a paper. You actually see it, you see the triangle pointing towards you. So the bottom length of the triangle would become the distance on the map where you normally see. But because a map is two-dimensional, you can't really see the height of any features. So how do we denote or describe these heights? Is by using contour lines. Each contour lines represent a certain height above sea level. So by actually drawing these lines and pattern according to their heights, you can also denote the height itself by counting which line is it at. You can also roughly gauge the slope depending on how far it is, and also the shape of the mountain, because the lines follow the shape of the mountain. So how do you see whether or not is it a steep slope or a gradual incline? You look at the distance between each contour lines. All right. And how do you see each height? Each line will have a number associated with each line. So if you, when looking at the map, look for those numbers, and every fifth line or every fifth consecutive line, it will be thickened so that you can, it'll be easier for you to calculate and multiply the height. All right. Next. So here are some examples of what the contour lines can quickly show you about the shape of the land. So looking on the left, you have the example of the contour lines, and the right, the actual shape of the mountain or hill when you are on ground level. So looking at the map, the top example, all right, you can see the contour lines are fairly equal in distance from each other, going towards the going in circles towards the center. So it is gradually increasing in height towards the center, which is the peak, which is just a circle, having no other circles within it, because that is the highest it can go. So then you have a somewhat a mountain that looks like a pyramid, as compared to the lower example where you have a hill with two peaks, because you have two circles with a gap in between. All right. Why you have a gap in between here? Because again, there is no landmass for them to indicate the, sorry, yes, no landmass there, so they don't need to draw any contour lines in that space. All right. So it's a very quick and easy guide to how to read contour lines. Okay. So pop quiz. Try to match the shape to the contour lines. All right. Look carefully at the shape. Try to find the peak or the height. All right. So again, showing you this. Here you have two peaks higher than it. It's not a gradual slope like the one in green, is because you have a separate circle here. So this contour line indicates that there is a rise in elevation. Therefore, you have two peaks, although the peak on the left is lower compared to the peak on the right. Okay. Oh, Smelly Bee went up, along with Amazing Hair and Royal Lemming. Ooh, lemming. We have a lemming among our mates. All right, another question. What is this study called? You know, the study where you look at surfaces, and then after using surveying, you draw it on a map. What is it called? I mentioned it at the very beginning. Good. It is called topography. Next. Oh, Fairy Dragon went up again, catching up. Another question, which is multi-select. What can you interpret from contour lines? Just by these lines itself, what can you deduce, or what information can you get from these contour lines? This is a multi-select question, so there might be more than one item you need to select. So just select all the things that you think you can, all the information you can get by looking at contour lines on a topographic map. All right, good. So you can actually get three things from a topographical map. Sorry, from looking at the contour lines, which is the height again, by reading the number on the line, the slope by seeing how far each contour lines are, and also the shape just by looking at how the shape of the whole contour line. Okay. So another thing I wanted to point out about why it would be good to know about these contour lines, or who would usually want to learn how to read these contour lines, are people who enjoy outdoors, those who like to go trekking, or perhaps you're a scout, you're trying to find a good place to camp, and also perhaps mountain biking or anything to do with rough terrain. So you would definitely want to know, are there land features where is it easy to climb, or is it dangerous, or is it safe, flat ground for you to pitch your tent? So you can look at contour lines to find out these places. You look for flat areas by looking for a big surface area where there are not many contour lines, because there are no rise and fall in elevation. You can look for certain obstacles as well by looking for valleys, cliffs, mountains, hills, or perhaps even like giant, what do you call it, bowls, or bowl-like valleys that might block your journey or travel the route that you have planned to go. So I hope this is a useful tool for those who are in scouts or those who enjoy outdoor activities. So not only so again, like we said, topography is the study of these land features and the use of contour lines on these maps. So not only, again, are they used for recreational activities, like I mentioned, for all those outdoor activities like camping, mountain biking, and hiking, but they're also used in industrial application, where you have astronomers who can use this method of studying landmass and recording down their features on maps, where they look into the telescope and study the moons, and asteroids, and they study the how each celestial body have certain type of features. So perhaps, let's say for Mars, again, they can look for a safe place to land their Mars rovers, so that they need find a flat surface or a place where there's no mountains, and preferably no steep terrain, so they can plan out where would the rover travel with the least amount of resistance. Or perhaps engineers who look at the maps and plan their roads, where they can see whether the road will it be an even road, or do they have to level certain mountains to create a straight road, or will it be a winding road going upwards? Will it be a steep road that only powerful vehicles like four-wheel drives are able to go up, or do they want to make it easier for much more civilian vehicles to go up, where you don't need such a high-powered engine to climb the road? or perhaps even just a high place to build a cell tower so that nothing will be blocking its signal, or even a deep enough valley so that they can build a hydroelectric dam. Or even geologists, they can, just by looking at the maps from different time, they can see how each land masses changes, so they can understand the tectonic activity, or how they can study the landforms of each continent and regions. And also perhaps sometimes they are consulted on where to dig mines, so they would find the closest spot to start the tunnel, where it's the easiest work or the shortest amount of work to dig those mines, and also whether or not is it safe, or are there any nearby dangers. So again, if you're interested to learn more about all these maps, or how do you read them, or where do you get information, GIS Geography is a good source, where not only do they provide maps mainly in the US, but they provide a lot of articles on how to read these maps, what devices can you use to read these maps, what application can you use after knowing all this information, and any other thing that is related to geography which you are curious about. They would usually have an article written about it. And if you want to look more on where do you find anywhere locally where you want to find, OpenStreetMap is a free database which you can use to actually find the terrain features or contour map of your own place, your local region. Okay, so let's say, for example, you're living in Penang, you can go to OpenStreetMap and look for Penang, and search for where you want to go camping and get the topographic map. So again, that was GIS Geography, okay, which is the Geography Information System and Geography, that's their name. And also OpenStreetMap, it's open, being that it's by the public, for the public, that kind of open, and it's a street map. Cool. All right, so we have learned about the Pythagorean Theorem, okay, the theory. We have applied the application, how do we use it, or what is it used for, kind of thing. Now, what kind of jobs usually use the Pythagorean theorem, and also in the way where they would need to draw contour lines, or planning out the boundaries? So there are many jobs, like I mentioned. There are astronomers. Astronomers use the maps. They don't really make the maps, but again, they just use it with the same concept, which is the Pythagorean theorem. They can know how to read those maps, along with engineers again, how to read those maps, and geologists how to read those maps. But to actually use the Pythagorean theorem almost on a more regular basis, because it is required in the job process, one of it is the land surveyor. All right, the land surveyor is actually a professional that is licensed to conduct physical site surveys and check for accuracy of measurement data. So these are the people where you would see on the roads. They will have a tripod with a device on top. They will go around different places looking into their theodolite or total station and getting measurements. If they're doing it again after someone else has already done it, that is because they are checking for the accuracy of the measurements. So these are the people that actually check, are the points on the map the same as the points in real life? Or where are the points on the map the points in real life? Let's say if you have a building, you can use the building as a reference for a map. But how about in a forest? Not all maps would note where are certain trees or what. But using these land surveyors, they would use a technique called land surveying, where they can accurately find the positions in real life. So remember again, the Pythagorean theorem, you have 3 points or 3 lengths along with the angles. So by using those tools, they will go to each point and then calculate the distance, calculate the angles apart from where they move, to find out where are these points on the map in real life, so that you can actually know where certain points are or where to start. Let's say if you're drawing a boundary, or are you constructing a building at the correct angle. Let's say it's a very big building, so it's quite hard to always checking the angle each brick you lay. So they would find the point so that you can lay a string straight away for a guide. Okay, so again, why are these important? Land surveying is important because when you are buying a property, or when you are signing, you're buying a property, you're deciding where do you want to build your house, or you have a dispute on whether or not that land belongs to you. Usually you would need a land surveyor to verify that these lands are the same lands stated on paper. So where does your land start? Let's say you and your neighbor have a dispute over a certain part of the land or certain corner of the land. So a land surveyor will come in, look at the documents of your land deed, seeing how big your area is or where does it start, and tell you in real life where that point starts. So he will then they'll usually put a nail or screw along with cement to show you that the point is there, and then they'll leave their mark there. Or again, like in engineering, where do you lay your foundations? Where do you start your four corners in normal sense? So again, they would go to the points, lay it out, and then making sure that it is all at the right angle. If let's say your building is square or whichever shape your buildings are at, they will help you measure each point. And also, if let's say your building is on a different elevation, they can also do that. They can tell you, let's say you're building a house on a hill, they can tell you where the four corners you need to build a house, though, even though it is at different elevation. So that's the job of the land surveyor. So one of the tools they use is called the theodolite. This is a very basic tool that has been in existence since the ancient times. But the one in the picture here, this is a theodolite from the 17th century. Okay, you use these devices to calculate the horizontal and vertical angles. So how high is it from your normal plane going up, the angle, or left to right, the angle between left to right sides. Yeah, that's it. Another equipment would be the level rods. These are the rulers where they use to calculate the height between different points. So let's say you have a slope that is not so straight, that is going down, and then you will put the level rod on one point, see how high it is, then along with the theodolite on the other point. And then they will look through the theodolite, which has a telescope. Let me go back. Telescope, all right, here. So they'll shine a light through the telescope to see whether or not does it line up with the level rod. Is it at a perpendicular angle? So to show that it is level, and to know the height difference. So just by using these two tools, you can actually already get the angles, and you can also get the sides, where you can then find the three-dimensional triangles, be it vertically, horizontally, or on the z-axis, whichever way or however way you rotate the triangle, you can find those 3 points, and therefore allowing you to find position of points in 3D spaces. But again, now we are in the modern age, we have the help of electronics. So by combine that, there is this equipment called the total station, or total stations if you have more than one, where it has an inbuilt theodolite, where you can see in the middle that telescope, thingy, along with an onboard computer to store data and also to record the GPS. So the other benefit of using this modern tool is that not only does it streamline your work process on calculating angles, but also helps you to know the GPS positioning and also record them so that later on you can input to a computer. Yeah. And also through the GPS, you can calculate the distance in between them. Okay. So normally who would like or enjoy being a land surveyor? You have people who likes maths because again you have to keep on calculating the angles, the distance, and the area at moments. Those people who enjoy engineering, they want to be involved on the proper construction of buildings or facilities. So a land surveyor would be a crucial step in that building process. Or people who just like geometry in general, where you like to play around with shapes, you can use triangles to find all the positions in real life. Okay, so with that, let's have a final quiz regarding all that we have talked about or learned about today. Shall we? So again, let me remind you, two devices, one on your computer screen to look at the questions, one on your phone. And also be reminded to prepare a calculator if you have not yet prepared a calculator. So I will give you 1 minute if you haven't prepared a calculator to go get a calculator. All right. And for those of you who have already prepared a calculator, you may take a short break, stand up, stretch out, or go get a glass of water, which I might do myself. So again, I would like to remind those of you who are still with us that we will be having 3 winners this week. So at the end of the quiz, there will be a Google Classroom link posted in the comments. Do use that link to claim your prize later on if you are the winner of today's STEAM trivia. Okay, I believe that is enough time for those who didn't have a calculator to go and grab a calculator. So with that, let us begin with today's quiz. So again, the Pythagorean theorem. What does the Pythagorean theorem state? Is it as the image shows you, where the hypotenuse is equal to the sum of the squares of the two sides of a right triangle? Is it true? Is it false? False. This, again, the Pythagorean theorem states that you need the square of the hypotenuse for it to be equal to the sum of the squares of the two short sides. So this phrase is basically saying a square plus b square equals to c without the square. The Pythagorean theorem requires you to have the square on each side. So the correct statement needs to be the square of the hypotenuse is equal to the sum of the squares of the two short sides of a right triangle. Okay, let's move to the next question. Oh, amazing hair is on fire. We have a hot bunny. Double points, where you need to calculate the bottom side. So this is a question where you need your calculator, take out your calculator and try to find the length of the bottom sides. You have 2 minutes, which is ample of time for you to key in your length and calculate. So again, the formula, if you have forgotten, is a square plus b square equals to c squared. The correct answer was 12. Yeah. So one unique thing I would like to point out about this, there are certain numbers which are called the Pythagorean Triads, where it will always be perfect numbers, which is like whole numbers. So that's extra tidbits for you. So in this case would be the 15, 9, and 12, which forms a Pythagorean triad. On to the next question. We have Happy Pigeon flying up in the scoreboard. So again, multi-select, you have you can choose multiple options for this. So again, back to topography. What is it used for? What are the applications which you can use? Can you use topography to dig mines, or plan to dig where to dig mines, or can you use it where to build roads, where to land on Mars, or where to go foraging? So yeah, you can use it for 3 things if you remember. You can use it to plan where to dig mines based on the elevation and depression of the map. So you can find the closest point to the resource where you want to dig up to start digging your mine. And also where to build roads. You can see whether is it high enough, low enough, or level enough to build your roads. And also where to land on Mars, looking for open spaces so that it's safe to land your Mars rover. You can't really use it to plan where to go foraging because it does not denote where plants or trees are, where edible food sources are. You can only know how to travel through it. So therefore, the green option, where to go foraging, is incorrect. But the other 3 is applicable. Oh, we have a winged pony flying in. All right, the GIS in gisgeography.com stands for who? Is it geographic information systems? Or is it global initiative services? Or is it good in science? Oh, we are good in science. Or is it geothermic infrared studies? Yes, it is geographic information systems, which is again a very general term in geography. It's all those systems which we use to collect geographical information like satellites, maps, telescope, and computer databases to collect all this information. Ooh, amazing hair is in the lead, running ahead. To the next one. Oh, another one. Match the contour line to the correct shape. So again, contour lines, they can tell you the height, the slope, the shape. What is the actual shape of this contour line? Yes, the correct answer is the picture in yellow. So why is it the one in the yellow option instead of the one in red? It's because here you can see it is a lower gap because there's only two contour lines and not many in the middle. Whereas if you look at the red option, where it's supposed to be higher in the middle, if it is the red option, there should be more contour lines in the middle. So maybe like 4 and 5 and not as many circles in the peak. So because the peak has more contour lines, it means that it is higher compared to the gap in the middle. And therefore, it is the yellow option where it has a deeper valley. Good. Oh, Perry Dragon is back and is on fire. Ooh, another multi-select. So the surveyor tools in this picture is called what was it called? Is it called a theodolite or GPS station or a total station? You have 13 seconds left. 10 seconds left. 5 seconds left. Ooh. Decisions. Right. So again, you have two tools actually in it because in each total station you have a theodolite. So therefore, you can actually call it specifically by the part of it or as the whole object itself. But the thing about modern day theodolites, they actually look quite similar to total stations. So to actually differentiate between the two for the modern version, you will need to check whether is it able to actually record GPS location. Okay. Amazing Hair is in the lead. Ooh, Amazing Hair is doing good. All right. So with that, that was the end of the quiz. So for this next question, this is just a verification question so that we know it is you who won the Kahoot quiz. So just type here, what is your favorite food? You know, try to put something unique where other people won't have a similar answer, so that you don't accidentally have a matching answer with another person who is able to claim your prize. So like, try to put something unique-ish. You know, can be something your mom cook, or something close to your house, or something you had in a foreign place where perhaps you don't think many people have went to, or something you created yourself if you are, you know, a creative in cooking, a up and coming chef. Or maybe you can even just put the ingredient of the food itself. Okay, so we have different answers. Good. No apple. Yeah, I put apple. Okay, next. So yeah, and with that, thank you so much for joining us today for this week's STEAM Trivia, the Pythagorean Theorem. I would like to thank the US Embassy and also the American Tech Corner for supporting this STEAM Trivia. And for the winner later on at the podium, do remember to go to the link posted in the comments. And just some special wishes from our producers. Happy Diwali to those who are celebrating in the coming weeks, and also stay safe and stay healthy in this season. And with that, let us look at who are the winners. Oh, Perry Dragon is the third place. We have Smelling Ibex in second, and the first is, drum roll, the Amazing Hair. Ooh, turnabout. Runner-ups is the Winged Pony, and in fifth place is Royal Lemming. So congratulations to our winners. Hope you like the STEAM trivia, the question set, and also the knowledge gain, so that you can, you know, go out, be inspired to look into science, look at all things sciencey, even if it's maths, you know, look at numbers and find how to use it, whether it be drawing art, drawing maps, or making buildings. And again, this marks the end of STEAM Trivia Season 2. Those of you who have been with us since the beginning, hope you have enjoyed this long 5-week journey. Those of you who have just tuned in for this week, hope you enjoyed the small taste you got from STEAM Trivia and at least managed to learn something from this. And with that, I am Adriel. Thank you so much for joining me this Sunday morning. And yeah, stay safe, stay healthy. Bye.